All right, today's lecture is going to be on section 4.5, greatest common factor and factoring by grouping. All right, in this section we begin our study of a mathematical operation called factoring. To factor an integer means to write the integer as a product of two or more integers. To factor a polynomial means to express the polynomial as a product of two or more polynomials. For example, in the product 5 times 7 equals 35, the number 5 and 7 are factors of 35. And the product 2x plus 1 times x minus 6 is equal to 2x squared minus 11x minus 6. The quantities 2x plus 1 and x minus 6 are factors of that polynomial 2x squared minus 11x minus 6. The greatest common factor, GCF, of a polynomial is the greatest factor that divides each term of the polynomial evenly. For example, the greatest common factor of 9x to the fourth plus 18x cubed minus 6x squared is 3x squared, because, as you can see, 3 goes into 9, 18, and 6, and x squared goes into x to the fourth, x cubed, and x squared. Right? So to factor out the greatest common factor of a polynomial, follow these steps. Now again, you can use those steps. There's nothing wrong with it. But as I don't know. I teach so many classes. I forget what I say in what class. But if and I'm sure you've all heard of the thing. Give me step-by-step instructions on how to make a peanut butter and jelly sandwich. Well, the thing is, I mean, you could do that, or you can just make a peanut butter and jelly sandwich, right? Um, you don't follow steps 1 through 3. That's my point. But I'll put it there just for fun. Right? Instead, we're just going to go at this the way I want to. Right? So factoring out the greatest common factor, 12x cubed plus 13. I'm sorry, plus 30x squared. Okay. Well, what's the largest number that goes into 12 and 30? Well, that's going to be 6. And what's the largest number, or what's the largest multiple that will go into x cubed and x squared? And that's going to be x squared, right? Because x squared goes into both x cubed and x squared. Now, really quickly, I feel like there might be some confusion because you'll be like, wait a minute, x squared doesn't go into x cubed, right? Because we have it should be x to the fourth, right? Well, if you have x times x, okay, it's basically saying how many x's, and then x times x cubed here, x squared here, right? We see that obviously there are two x's in x squared, and we can obviously take out two x's that are in x cubed. Okay, so that's why we can say that it is indeed the greatest common factor, right? It's not a multiple. It's not a multiple of 2. Right? It is just how many x's can I take out of both. And then B. So what can I take out of 12, negative 30, and negative 3? Well, that seems, well, I'm not gonna say it seems obvious, but I mean the smallest number there is a 3, right? So I can say 3. I can pull out a 3. I can also, well, that's my lowest integer. What about variable c? It looks like just one c can be taken out, and it looks like just one d can be taken out. Right? And I just realized that maybe what I should do is actually, because it literally says factored out. I probably should have factored it out, right? So the greatest common factor of a is 6x squared. So if I take a 6x squared out, okay, what remains, all right, if I take a 6 out of 12, right, it's going to be a 2. And then if I take x squared out of x cubed, it's going to be an x. If I take 6 out of 30, 30 divided by 6 is 5, so plus 5. And then there is no, I take an x squared of x squared, so I'm done there. Okay, so I got a little ahead of myself there. I'm sorry. What did I say? Well, let's just start over, whatever. So the greatest common factor here, I think we said was 3CD, right? So if I take out a 3CD, what I have left is 12 divided by 3 is 4, and then I take away 1c and 1d, so I'll have a cd squared. And then if I take 3 out of 30, it's going to be a negative 10. And then take out 1c and 1d, so it's going to be c squared d. And then, well, if I take a 3cd out of 3cd, I end up with a negative 1. Okay. right, so let's just snip this. It's pretty small to deal with here. All right, so this reads, factor out the quantity negative 5a squared b from the polynomial negative 5a to the fourth b minus 10a cubed b squared plus 15a squared b cubed. All right, so what is the greatest common factor? Well, it's kind of telling us, 5a squared b, right? So the greatest common factor, 5a squared b. However, in this case, we'll be factoring out the opposite. We're going to be factoring out the negative of it. All right, so if we take out a negative out of all of these, remember, you're essentially dividing by a negative number, right? So on the previous example, we essentially did, 12 divided by 6, which was 2. 30 divided by 6, which is 5, okay? In this particular case, we're going to be dividing by a negative 5, okay? So if we take a negative 5 out of these, so negative 5 a squared b out of negative 5a to the fourth b, we end up with a squared. And then we can see what follows after. All right, nothing tremendously different. We're just factoring out a negative number instead of a positive number. So same as example 1. Right. Next, we're going to talk about factoring out binomial factors. So, factoring out binomial factors. The distributive property may also be used to factor out a common factor that consists of more than one term. So let's check this out. So factor out the greatest common factor. Let's try this. Let's rewrite this as x cubed times what's something that would be very memorable. Let's just make it a y. Whatever. We're just gonna make it a y. Y minus x y minus 9y. Okay. If I wrote this problem out, it's very obvious what you factor out, right? You would factor out a y, right? Because a y would be taken out of this entire problem. So you'd say y, and what remains, you'd have x cubed minus x minus 9, right? Okay. So what's essentially happening here is, if you notice, I replace the x plus 2's with y's. So instead of factoring out the y, I'm essentially going to be factoring out x plus 2. Okay, so my solution is going to look like this. Right, I wouldn't say solution. Factoring out the greatest common factor is going to look like this. X plus 2 is factored out, and what remains is x cubed minus x minus 9. Okay, same procedure as if I said it was a y. Now, factor by grouping. Okay, so let's see. Again, we have our steps. Okay, but we'll put it down. But I just make my peanut butter and jelly sandwiches a little bit different. And here's how I will explain to you how I make my peanut butter and jelly sandwiches. All right, so if you've made it this far, obviously you're in college, you've taken math courses in high school, you should be pretty darn familiar with something called quadratic equations. Okay, we use quadratic equations ad nauseum in this course, in college algebra, and pre-calculus algebra, and even forms of quadratics in calculus. Okay, we use them because they're very easy to deal with, and we can do so much stuff with them. My point is, you're going to see them a lot, and you need to know what to do in those situations. So whenever you see from now on in any of your math classes, right? Whenever you see 4 terms, the thing you need to think right off the bat is, I'm going to split this sucker right down the middle. Okay, and I'm going to factor by grouping. And we'll see that happen quite often in this course and the next. So let's explain what I mean by that. So 6ab minus 21a plus 4b minus 14. Okay. So I'm going to split this right down the middle, bam, 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 bam. So what I'm going to do, again, factor by grouping, means I'm grouping the left side and I'm going to be grouping the right side. So here's what I'm going to do. The left side of that dotted line, what can I factor out? Okay, well, it appears that I can factor out an A. That's it. I can factor an A out. So if I factor an A out, I am left with 6B and minus 21. Okay. Now, if you do factor by grouping correctly, what's going to happen is on the other side of the dotted line, whatever's in your parentheses should be the exact same. Okay. So it should be the exact same. Not that it will be the exact same, but it should be the exact same. Oh no, I messed up. I know I messed. No, I messed up there. Sorry. It should be a 3A. Okay. Sorry. So if you saw that, my bad. Um, I can factor a 3 out of both of these, so it's going to end up being a 2b minus 7. Okay. So on the right side, what can I factor out of the right side? Well, it looks like I can factor out a 2. Okay. So I'm going to factor out a positive 2, and what remains is 2b minus 7. Okay, so now it's essentially the same thing I saw before, right? Like if I said this was a y, this was a y, I know I could factor out if it would be 3ay plus 2y. I know I can factor a y out of both of those, right? Same procedure as the previous example. Instead of factoring out a one term, we're going to factor out an entire binomial. So I can factor out 2b minus 7, and what remains is 3a plus 2. Okay, and that's it. That's factor by grouping. Again, you can follow those steps 1 through 3, but I'm telling you, from in this class and honestly probably the rest of your math classes, you're going to want to or not divide, but you're going to want to split the terms down the middle when you see 4 terms. Okay, when you see 4 terms, 1, 2, 3, 4, split it down the middle. And we're by the way, this is definitely something you need to not mess around with and fully grasp, because whenever we get to quadratic equations, we're going to be doing this procedure quite often. Okay, so more factor by grouping. Let's see. They split it down the middle. Nothing. I don't think there's anything much to this. Yeah. Same as before. Now this one is different. Okay, so let's do this one. So example 6, factor by grouping. So I said the first thing we're going to do is split it down the middle. So let's go ahead and write this. 24. I mean, this is a real pain to write because I'm pretty sure I'm going to have to rewrite this. Okay. So I said the first thing you do whenever you see these 4 terms, again, this is one term. The terms are split by these signs, right? That's 1 term, 2 terms, 3 terms, 4 terms. Whenever you see 4 terms, the first thing you're going to want to do is split it down the middle. Okay, so we split it down the middle. Let's go ahead and dang. All right, so I'm autopiloting a little too hard here. So let's. I say that because I'm looking at this particular problem, and I should say whenever it goes to factoring, don't make the mistake I just almost did. Make sure that you factor the all 4 terms first. All right, I got ahead of myself because I know we're factored by grouping. I autopiloted. I'm sorry. The first thing we need to do whenever we deal with any polynomial is see what we can factor out of the entire problem. Okay, what can we factor out of this entire problem? Well, it appears the number 3 goes into all 3 of these numbers. All right, and it looks like I can take out a p. Looks like I can take out one p and one q as well. Okay, so it looks like I can take out a 3. So what I'm going to do is I'm going to go ahead and erase this and rewrite it with the 3pq taken out because space is very valuable, especially for this particular problem. So we're going to have a 3pq. Okay, we're taking a 3pq out. All right, and whenever 24 divided by 3 is 8, I take out a p, so pq minus 6p, q is already gone, plus, looks like 20q, and then minus 15, and it's simply minus 15. Okay, so I should have done that first. I'm sorry about that. And then once we get to this point, we're going to split it down the middle. Okay, so real quickly, make sure you keep your well, let's see. Let's put a bracket actually, because I know I'm gonna have to use parentheses. So 3pq. Make sure you bring down what you have on the outside. Otherwise, you're going to well miss the problem. Okay, so what can I factor out of this term here? Well, it looks like I can factor out a 2p, and what remains is going to be 4q minus 3. What can I factor out of the right side? It looks like a 5, so it's going to be, I can factor out a positive 5. So what remains? It looks like a 4q minus 3. All right, so these are the same, so we did it correctly. So now I can just simply rewrite this as 3, and again, remember this 3pq comes down, and it's going to be 4q minus 3 times 2p plus 5. Okay, so that wasn't actually as bad as I thought it'd be. But that is factor by grouping there. I guess the main takeaway here is don't make that mistake I just made. You know, don't try to tackle this whole thing. Make sure you factor out of the whole problem before you start diving in. All right, so last problem here is factor by grouping, and if you need to rearrange as necessary. So what we're going to do is we're just going to snip this whole thing, because again, it's the same procedure, but just one little kind of warning sign here is, okay, so if we factor this polynomial, if you say, okay, so Professor Brown said, if you see 4 terms, split it up, split it right down the middle, okay? So if you split down the middle, like this, and then you factor by grouping, I said you want to have what's in your parentheses to be the same. They are obviously not the same, okay? That sucks. So what you have to do is you have to rearrange the terms, okay? So we did, in this particular case, we did 4x minus 8a, so basically we just swapped the negative 8a and the 6pa, swap sides there, okay? It doesn't matter. It doesn't change the value of the equation, right? And then once you did that, and you split it down the middle, you see that you do indeed have the two terms be the same, and we are able to factor by grouping a lot easier, right? That does conclude today's lecture.